In this lesson, we're going to learn how to identify integers, rational numbers, irrational numbers, and real numbers. And these are all just different kinds of numbers, different ways of categorizing different numbers that we use. Okay, so the first one is integers. So we've been introduced to integers already. The integers are just simply the positive and negative whole numbers. So they include -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and so on and so forth in every direction. Again, the integers, fairly simple. They are just the positive and negative whole numbers. So it doesn't include numbers like 1.5 or 5/4, things like this. These are not integers because they are not whole numbers. The next thing that we'll learn about is rational numbers. And so the definition of rational numbers are they're numbers which can be written as a ratio of two integers, or a fraction p over q where q does not equal 0. So what do we mean by this? Well, this includes numbers that I mentioned earlier, like 1.5 or 4/5, or even the number 1, because 1 is equal to the fraction 1/1. Same thing with 5, that is equal to the fraction 5/1. So if you notice, the integers are a part of the rational number. So every number that is an integer is also a rational number. However, every number that is a rational number is not an integer because, as we mentioned, 1.5 is not part of the integers. And again, just a few more examples. The number 0.3333 repeating, well, that is equal to 1/3. So that long string of numbers, that is a rational number because it can be written as a fraction. So again, integers are any positive and whole number. Rational numbers are any number that can be written as a fraction. Okay? So then, if the rational numbers are numbers that can be written as a fraction, then the irrational numbers are numbers that cannot be written as a fraction or a ratio of two other numbers. So this is reserved for certain types of numbers, like possibly the most famous example is the number pi, also denoted as pi, because this number is roughly equal to 3.14159 and so on and so forth. The number pi never finishes. Because it never finishes, it cannot be written as a fraction. If it cannot be written as a fraction, then it is an irrational number. A couple more examples of numbers that are irrational is the e function. So e, which is equal to roughly 2.71828 and so on and so forth. Again, because this number never ends, it cannot be written as a fraction. One more pretty common example is the square root of 2. The square root of 2 is roughly equal to 1.4142135 and so on and so forth. So again, any number that never ends, again, it's different than a number like 1/3, which is 0.3333, that never ends, but that number repeats. These are never-ending digits, but there is no repeating pattern. So because there is no repeating pattern, it cannot be written as a fraction. So these are just a few examples of irrational numbers. So again, where we said that all integers are rational numbers, no rational number and no integer can be an irrational number. So they're two completely separate concepts. And then the final concept that we have are real numbers. And the real numbers are just simply defined as every type of number that we've already mentioned. So this includes the integers, This includes irrational numbers. And this also includes the rational numbers. So any number that is one of these three is also a real number, okay? So I'm just going to draw up a Venn diagram to give us a better understanding of these four different concepts. So imagine we have our Venn diagram. So inside, everything that is inside the circle is what we will call the real numbers. Okay? And then inside the real numbers, we have two separate categories. There are the rational numbers. And again, the rational numbers includes anything that can be written as a fraction. And then there are the irrational numbers. And again, that includes numbers that cannot be written as a fraction, like pi and e and the square root of 2. But then inside the rational numbers, you also have what we call are the integers. Okay? Because the integers include whole numbers which can be written as fractions, those whole numbers over 1. So again, some examples of this. So all of these numbers are real numbers, but inside the rationals, we would have numbers like 1.5 or 4 over 3. Again, numbers that can be written as ratios or fractions. But inside the ratios, you also have whole numbers such as 3, 7, 100. These are all integers because they're whole numbers, but they're also inside the rational numbers because they can be written as, a fraction of that whole number over itself. But then completely separate of the irrational numbers, or completely separate of the rational numbers, are the irrational numbers, which include pi, includes e, includes the square root of 2, and so on and so forth. So this might seem like kind of a confusing concept, so I'm going to, make a little analogy to make it a little bit more simple. So imagine, again, this will be kind of cheesy, but you just go with it. Imagine you have a house. And inside the house is the list of all real numbers. But inside the house, let's say you have your kitchen, which inside the kitchen will be, say, the irrational numbers. But then also in your house, you also have your bedroom. And then inside the bedroom, you also have we'll call it a closet. So everything that's inside your closet is inside your bedroom, and everything that is inside your bedroom is inside your house, but nothing that is in your kitchen is inside your bedroom. Again, this may or may not be very helpful. It's just another way of looking at it, again, because the house is like the real numbers. The kitchen is like the irrational numbers because nothing you find is in the kitchen will be in the bedroom. Nothing you find in the irrational numbers will be in the rational numbers. Then your bedroom is like your rational numbers. Nothing you find in the bedroom will be found in the kitchen, just like no rational numbers will be found in the irrational numbers. And then inside your bedroom is the closet, which that will include your integers because all integers will be found in the rational numbers, just like all your clothes will be found in your bedroom. So again, hopefully that kind of cleared things up a little bit. I know it can be kind of a confusing concept. It's something, honestly, I didn't have a complete and entire grasp of until I got to college, but it's just something we want to introduce to you a little bit. So again, 4 different concepts. There are the real numbers. Inside the real numbers, you have the rational numbers. Inside the rational numbers, you have the integers. Outside of the rationals, but inside the reals is the irrational numbers. And that is the difference between integers, rationals, irrationals, and the real numbers.